Okay, so the big thing that I want you to know about limits is that in order for a limit to exist, it has to be a real number. So remember that if something goes to infinity, like there's an asymptote, the limit does not exist. So it has to be a real number, and it has to be the same number as we come from the left side and the right side. Sometimes we call that the general limit, but we need to make sure that it's the same coming from both the left and the right. Okay, so let's look at the next page that we should have put in your notes here. And there's 3 conditions or 3 times that a limit might not exist. Okay, so you need to know the first case is one that we sort of looked at already, that the limits differ on the left and the right. Okay, then we say it does not exist. So an example here, or how you would justify that, here is the graph. And you're going to show both of these parts. And you've got to write it exactly like I have it written here. Okay, so you can't write that differently. So the limit as x approaches -1 from the right. I don't know if you guys can hear the buses outside. And the limit as x approaches -1 from the left. Okay, and you're going to show that they equal different things. And then there's your proof. So the limit does not exist because the limit coming from the left does not equal the limit coming from the right. I want to make sure that you have enough time to write this down. I guess you can go back and look at the video. Or maybe not. I don't know. Okay. The next thing that where a limit will fail to exist is if we have what's called oscillating behavior. This I have not seen come up in Calc AB or BC. Okay, so it's just something I want you to know. I'm never going to make you prove it. I just want you to know if something oscillates. Oscillates means going back and forth, back and forth, back and forth. Okay, so it looks something like this right here. Okay, and again, all I want you to do is to say there is no limit when you have oscillating behavior. Okay, so it's too hard to see in the picture, but let's say that we wanted to look at 0. Okay, well, we can't see it, but if we went and we could zoom way, 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 way in, and we could see like 0.1, and we looked at 0.1 from the left and 0.1 from the right, we would see that the limits are 2 different things. Okay, so again, I'm not going to have you ever prove that. I just want you to note that oscillating behavior, we would say the limit does not exist. And we remember, sometimes we just write DNE for does not exist. Okay. Now, the third case, and I should put it here. I don't think I wrote it. We'll say that there is unbounded behavior. Okay, so this one, I want you guys, it seems like it confuses students a lot at first. So let's say that we're headed towards 2 right here. Okay, so if I'm coming from the left, this function's headed towards infinity. As I'm coming towards 2 from the right, now remember, it's from the right, not towards the right. As I'm coming towards 2 from the right, is headed towards infinity. We say it's unbounded. Now, they're both headed towards infinity or positive infinity, and we said, hey, if they have the same limit from both sides, then it exists. But remember, we said the limit has to be a real number. Infinity is not a real number. So technically, on this problem, we say the limit does not exist. Now, one thing that's peculiar is oftentimes, even though the limit does not exist, we will state whether it's going towards infinity or negative infinity, just so that we can give the end behavior of the graph. But technically, the limit does not exist. Okay, so here's what I wrote. Okay, so as I'm coming towards 2 from the right, it's positive infinity. As I'm coming towards 2 from the left, it's positive infinity. Okay, and I'm going to make a little note here because students ask me all the time if this means the limit does not exist. So we usually will write that it equals positive infinity. But remember, it doesn't exist. And that all this does is tell me that the function is, when it's x is headed towards 2, the function is headed towards positive infinity, but the limit does not exist. And you don't have to write that and that. I just want you to be aware that most of the time we give that, but you need to know the limit does not exist. Okay. Okie dokie. So now what I want you to do is I want you to fill this in. In order for the general limit to exist, the function has to do what? Or the limit or what? So you fill that in. Okay, and I'll show you what I put. So I just put that it has to approach the same y value from the left-hand side and the right-hand side. And that it doesn't matter if the function exists at that little spot or not. Meaning, you know, if I have like a hole right there, okay, it looks like it's approaching the same y value from the left and the right. I don't know if you can see that. It doesn't matter if there's a hole in the graph. It doesn't matter what's actually happening at 3. It just says, well, where is the y value headed towards? Okay? So just keep that in mind. It may or may not be defined there. And I just kind of added in that if the function is heading towards positive or negative infinity at the limit, or like the number that we're going towards, the limit does not exist. It's customary, however, to give the end behavior of the function. Okay, and then I want you to try those 2 problems on the bottom. Okay, we'll go over your solutions in class. Okay, one little piece of notes that I need you guys to take. And that is if we can get the limit from a table. Okay, and so it's going to be important that you can get it from a graph, which we've seen. It's going to be important that you can get it from a table, which we're looking at now. And it's going to be important that you can get it from an equation, which we'll look at tomorrow. But if I'm looking at the limit as x is approaching 3, I can just look in my table and say, what y value is that headed towards? And again, we don't even have 3 here. We don't care what happens at 3. We just care about where is it approaching? Where is that headed? Okay. So when I play this, I'll just pause the video so that you guys can copy that down.